This is Geometry B, Unit 4, Lesson 1, the Pythagorean Theorem, and its converse. So let's get right into it. The Pythagorean Theorem. Pythagoras was a Greek mathematician, a teacher of school of Pythagoras, around 550 BC. In terms here, that's about 2,500 years ago, 2,500, 2,600 years ago. Pythagorean Theorem. All right. And one of the best known rules that came out of it is something called the Pythagorean Theorem, which says if you take a right triangle, that is a triangle with a 90 degree angle, a single 90-degree angle, that there is a relationship between the sides of the triangle. Now, he wouldn't have put it in this term because algebra really wasn't a thing at the time. But basically, he said this. He said, if you attach a square on all three sides, okay, and I'm just going to sketch because I think it'll take a bit of time to draw. Okay, so basically, we're going to attach a square to this side. We're going to attach a square to this side. Forgive my voice. It sounds like I've got a little bit of a cold or something. Okay. And if we take another square and attach it to this side, so goes like so here. Okay, and I'm going to move things here a little bit. Okay. So 1, 2, 3, okay, 2, 4. There we go. All right. Here I am sketching it and still trying to make it perfect. Okay. Basically, what we're saying here is if I take the area of the red square and the green square, we'll call this a squared, and this b squared, that we get the same thing as the area of the hypotenuse squared. Okay, so that's the way Pythagoras would have understood it. The area of the squares on each edge have this formula. A squared plus b squared equals c squared. Okay. Again, he wouldn't have recognized A, B, and C, but the areas of the smaller squares add to the area of the larger square. Okay. And we can use it to solve right triangle problems. So, for example, okay, let's say I've got a right triangle, and this side is 3, and this side is 4, and we want to know this side. We can write this equation, 3 squared plus 4 squared equals x squared. Now, when implementing this, it's really important to recognize the one that goes by itself is the hypotenuse. Hypotenuse. It's the long diagonal. It's opposite the 90-degree angle. It's the longest side on a right triangle, so hypotenuse. So the hypotenuse in the Pythagorean theorem is always the one that goes by itself because it's the two smaller squares that equal the larger square. All right, so basically let's solve this. 3 squared is 3 times 3 or 9. 4 squared is 4 times 4 or 16. 9 plus 16 is 25. And now we can unsquare. And the unsquare, the anti-square or an inverse of squaring is the square root. Square root of 25. You can use your calculator if you want to. In Desmos, that's SQRT. Let me bring up Desmos here. SQRT. So if I want to find the square root of 25, I type SQRT 25, and I get 5. Or you can just think about it. What number times itself is 25? And the answer is 5. Okay, so the missing side is 5. Okay, so that's one kind of problem where the hypotenuse is unknown. It's a little bit different when one of the legs is unknown. So let's do that down here. Let's say I've got this. I've got 6x and 20. Okay. Yeah, actually, no, 10. Let's make it 10. Okay. All right. So the Pythagorean theorem says 6 squared plus x squared equals 10 squared. Remember, it's the long side that goes by itself. Okay, so let's work it out. 6 squared is 6 times 6, or 36. X squared is just x squared. 10 squared is 10 times 10, or 100. Subtract 36 from both sides. We end up with x squared equals 64. And now to unsquare, we square root. You can use your calculator, SQRT and Desmos, or you can just think what number times itself is 64, and the answer is 8. Okay, so x is 8. The missing side is 8. Okay, so that's how to use the Pythagorean theorem to find the missing side. Now the converse of the Pythagorean theorem. The Pythagorean theorem says if you have a right triangle, then the sum of the square of the legs is the square of the hypotenuse. The converse of the Pythagorean theorem says if the sum of the square of the legs is the square of the hypotenuse, then you have a right triangle. Okay, so here's the way you'll be asked the question. You'll be asked, is this a right triangle? A right triangle. Okay, is this a right triangle? And let's check it out here. Let's say 5, 12, and 13. If we have a triangle with those sides, is it a right triangle? Well, to test, we're going to test it with the Pythagorean theorem. 5 squared, the two smaller ones, plus 12 squared, will need to equal the largest one squared. 5 squared is 25. 12 squared is 144. 13 squared is 169. 25 and 144 is 169. So yes, this is a right triangle. Okay, this is a right triangle. Now, we can also tell if it's obtuse or acute based on this number as well. So let's say it was 5 and 12 and 12.5. Okay, that would make the large side smaller than 13, and this would be an acute triangle. As opposed to 5, 12, and 14, this is bigger than 13, which makes it a right triangle, so this would be an obtuse triangle. Okay, an obtuse triangle. So the converse of the Pythagorean theorem basically says if the sum of the squares of the small sides equals the sum of the square of the large side, then it is a right triangle.